So our only vocab word today, I think, is just midpoint. The midpoint of a segment is a point that divides a segment into two congruent segments. Okay, so here we go. Latanya is designing her living room and draws a floor plan to figure out where she wants to put stuff, basically. Now, she wants to hang a picture at the center of this wall up here between A and B. How does she find the center? If you were going to put a nail in the wall at the center, if you're like me, I don't like nail holes all over the wall. You want to do it right the first time. You want to put the nail in the right spot the first time, right in the center of the wall. Where are you going to pound that nail? How's she going to figure that out? How would you figure that out? Tate. Okay, so she's got it basically on a grid system where this is at 1 and this is at 12. Tell me on the grid system how you'd find the center. By looking at the grid there. What is the center of that? Chase. 6. 6 is halfway in between 1 and 12? Not quite. Not quite. What's halfway in between 1 and 12? Illy. 5.5. How do you get that? There's 11 spaces. But 5.5 isn't the center of this. 5.5 is part of it. But if I hit a nail at 5.5 right here, this is 5.5. Does that look like it's halfway in between A and B? No. It's 5.5 from 1 or 5.5 back from 12. Okay? So it's not at 5.5, it's at, so if you took, what Illy did is took 12 minus 1, which is 11, and took half of that to get 5.5, which is good. That's what you want to do, but you got to think of the grid. The grid doesn't start at 0. If it started at 0, perfect. But it doesn't start at 0. It started at 1. So then she had to add 1 onto that to get 6.5. And at 6.5, right here, that's where she should hang her picture, because that would be right in the center of that. Okay? Now, straight line, okay, is easy. Now she wants to put a lamp halfway in between C and D, okay? Which, again, is a straight line, but at what point would she put it? What would be the ordered pair that we'd put it at if she wants to put a lamp halfway in between C and D? How would we figure that out? Do you want to subtract again? Because we could. We could do some subtracting. Or we could do it a different way. What's halfway in between? I mean, you could look at the picture and kind of figure out what's halfway in between. Anybody know an ordered pair that looks like halfway in between? 10-7 looks halfway in between, doesn't it? This spot right here. Now, let's look at this. From C, D is 2 over and 4 down, right? So what's half of 2 and 4? 1 over and 2 down. That would be halfway. Okay? Halfway in between is the midpoint. Okay? So we could do this by counting over, counting down, and doing half of that. Okay? Now, there's actually a better way of doing all this than just counting, and that's called the midpoint formula. And this one, I want you to write down on a piece of paper because it's really important, and it's basically half of your quiz that you're going to have on Thursday. is the midpoint. Okay? You're going to get a whopping 2-question quiz. One question will be midpoint, one question will be distance. And so you need to know the midpoint formula for that. And I'd like you to memorize it for me. And it's a very easy formula. You add up the two x values and divide by 2. And then you add up the two y values and divide by 2. And that's how you find the midpoint of a segment. You add up the two x values and divide by 2. And you add up the two y values and divide by 2. So if we look at P and Q here, P is -4, -1. Q is 2, 1. So to find the midpoint, we take -4 plus 2 divided by 2. And then we take -1 plus 1 and divide it by 2. What's -4 plus 2? -2. So that is -2 over 2, which is -1. And -1 plus 1 is 0 over 2, which 0 divided by 2 is 0. And you can see in the picture that that makes sense. -1, 0 is the midpoint. So if we look at A and B here, A is at -3, 2. B is at 4, -2. Okay? So what's the first step of the midpoint formula? To take the what's and add them together. X's. So you take -3 plus 4, and you're going to divide them by 2. Then you add the y's. 2 plus -2. And you divide them by 2. What's -3 plus 4? 1. So you get 1/2. What's -2 plus 2? 0. What's 0 divided by 2? 0. 1/2, 0. Right there would be the midpoint. That looks right. Okay? With a lot of these, you can visually check and say, yeah, that looks good. Or maybe not. The midpoint of JL. What didn't they give us for JL? The ordered pairs. Yeah, they didn't give us the ordered pairs. We got to figure those out. So J, what does J look like? Where is J, Ella? -3, -2. And L. Where is L at, Haley Taylor? What's this ordered pair going to be? 2 and 2 and -3. 2 and -3. Okay, so I need to add my x's and divide by 2. So what are my two x's, Mike and Nelson? So you take -3 plus 2 divided by 2. Then I add my y's and divide by 2. So Olivia Bonner, or Olivia Meehan, sorry. Olivia Bonner's in a different class. Olivia Meehan, what is the two y's added up? So Chase Sturwald, what do you get for an x value?
You get 1/2.
Not 1/2.
Negative.
-1/2. And Christian Gabriel, what did we get for y value? -5/2. And we leave it as -5/2. What's the decimal version of -5/2? -2.5. So if we'd go -1/2, -2.5, it's sitting right there. That's a midpoint. Okay? Midpoint formula, pretty easy. Now, you know how we were doing the picture hanging, how Illy worked through that by subtracting and that? Well, if you're finding a point 3/5 of the way or 2/5 of the way, or 5/9 of the way between something, we got to use the Illy method. Okay, we got to do the subtracting and figuring out as far as we go. Because let's say we have something that starts at 2, 3, 4, 5, 6, 7, 8. What if I went, and this is A and this is B. If I said I want to go 1/3 of the way from A to B. Okay? If I want to go 1/3 of the way from A to B, I'm not looking for half, so I'm not adding it up and dividing by 2 anymore. When you're going 1/3 of the way or 3/5 of the way or however, you need to subtract and then multiply. So, how far is it from 2 to 8? How far is it from 2 to 8, Mia? 6. Okay? And what is 1/3 of 6, Ainsley? 2. So, am I going 2 this way to 6 or 2 this way to 4? Because I'm going from A to B, so I'm going 2 this way. So 4 is 1/3 of the way from A to B. So we have to do that same process to do this. So we're going from A to B, so we're going this direction. So we have to subtract. So I'm going to take the bigger numbers minus the smaller numbers. So for the x value, I'm going to take 13 minus 3. What do we get? 10. And then we're going to multiply it by 3/5. What's 3/5 of 10? 3/5 of 10. So it's 10 times 3, which is 30. 30 divided by 5 is 6. But I'm not done. 6 is not my point. Okay? 6 is how far I go. Okay? So for your x value, you start out at A is 3, and then you have to add 6 to it. Okay? So then you're going to get 9 for your x value. Okay? Now let's look at our y's. Okay? Let's look at our y values. How far is it from 11 to -4? How far is it from 11 to -4? Thomas? 15. Good job. I'm glad you didn't say 7. Because you have to take 11 minus a -4, which gives you 15. You have to go 3/5 of that. 3/5 of 15. So 15 times 3 is 45. What's 45 divided by 5, Ray? 9. So you need to go 9 away from -4. So your y value from A, you were at -4, and then you have to add 9 to that, and you're going to get -4 plus 9 is 5. So your ordered pair is 9, 5. That's 3/5 of the way. Okay? So you have to do a little bit more work there.
Have you called and confirmed with Canton that we're going down there?
No.
I would prefer you do that because on their landing page it says at Madison.
Oh, I'll call them right after I get done teaching. Yep.
Let me know.
Yeah, because I know their new AD. He emailed me the other day about other stuff. So, yeah. Yeah, exactly. Okay. So 9, 5. Everybody good with that, or should we do one more? 3/5, 4/3. Can't do 4/3 of the way. 3/5. We could do 3/4 of the way between something. Okay. So subtract, multiply, and then add to the endpoint. Okay. You'll only have one problem like that, and that is not on the quiz. Okay. That one won't be on the quiz on Thursday. Okay. Distance. To find the distance between things, Okay, especially at a diagonal. If it's a straight line, it's easy. You just count over, subtract, like we did the other day on the number line. But if it's diagonally, we need to work with the x distance and the y distance. Now, this makes a right triangle. There's an old Greek guy from way long ago that worked with right triangles, and he made this very famous theorem. Do you know the name of that guy? Mia? Oh, but you know the name of the theorem. What's the theorem? The Pythagorean theorem. And it's named after this guy called Pythagoras. Okay? So the Pythagorean theorem says this, that this is C, this is A, and this is B. Or if you want, this could be A and this could be B. Doesn't matter. It says the hypotenuse, the square of the hypotenuse of a right triangle equals the sum of the squares of the two legs of a right triangle, which is really complicated way of saying c squared equals a squared plus b squared. And we'll deal with the Pythagorean theorem a lot more later, but it helps us to find the distance between 2 points. Because c is the distance here. So the distance squared equals a, the difference of the two x values, and you're squaring that, and the difference of the two y values, and you're squaring that. Now, we don't want to find the distance squared, we want to find the distance. How do I get rid of a squared off of something? You do what, Thomas? Take the square root. So I'm going to do this to each side. Boom. So the distance formula equals x2 minus x1 squared, y2 minus y1 squared. And what I did is I get rid of my absolute values, because when you're squaring something, you really don't need absolute values because it's always going to come out positive. This is another thing I want you to write down in your notebooks. That's another one you'll need to memorize. That's the other half of the quiz on Thursday, is the distance formula. The other half of the quiz on Thursday is the distance formula. The distance between 2 points is the square root of x2 minus x1 squared plus y2 minus y1 squared. That's a really ugly looking y. Let me see if I can fix that. My computer, the touchscreen on that part of the screen is really wonky, so sometimes it makes it weird. But that is the distance formula, and we're going to use that today on several of our problems. Okay? So, if it's just a straight line horizontal or vertical distance, you can just count or subtract. But if it's diagonal, you need to use the distance formula. Okay. So here we go. Here's the distance formula. Okay, we just got done with the Little League World Series. I'm sure some of you were watching the Sioux Falls boys play in it. But here's a little baseball example of distance. A pitcher throws the ball to a batter who hits the ball to the shortstop. If the ball travels in a straight line between each, what's the total distance traveled by the ball? So the pitcher, boom, pitches to the batter. The pitcher is at 5-5. The batter is at 0-0. Then, also involved in this whole scenario is the shortstop, because the ball is hit straight to the shortstop. Shortstop doesn't have to move. So the shortstop is at 5-10. How far did the ball travel? Well, you got to figure out two distances here. Okay? So from P to B, that distance is the square root of the x's subtracted, 5 minus 0 squared, plus the y subtracted, 5 minus 0 squared. 5 minus 0 is 5. 5 minus 0 is 5. What's 5 squared? 25 plus 25 take that and add them together. It's the square root of 50, which equals 7 point what? Calculator. Everybody needs a calculator. What is the square root of 50? Get it out now because you're going to have to use it today. 7.07 something, 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 right? So approximately 7.1, round to the nearest tenth. All right. So that's pitcher to the batter. Now the batter hits it to the shortstop. We got to figure out that distance. Okay. So we go from 0, 0 to 5, 10. So it's the square root of 0 minus 5 squared plus 0 minus 10 squared. So it's negative 5 squared plus negative 10 squared. What's negative 5 squared? Is it 25 or negative 25? It's 25 because negative 5 times negative 5, a negative times a negative is a positive. So if you hit on your calculator negative 5 squared, a lot of times your calculator is going to come up with negative 25 because it's going to square the number first and put the negative sign on. So be careful with that. It needs to go in parentheses. Parenthesis negative 5, parenthesis squared, and then it'll give you a positive number. So be careful on that. Don't let the calculator talk you into a wrong answer. What's negative 10 squared? 100. So we have the square root of 125, which is like 11 point what? It's just barely bigger than 11. 11.1 something. 11.18, which is approximately 11.2 rounded to the nearest tenth. Now, there's a big part of this question that's right down here. This is not in feet. 1 unit is a foot. So this is the number of units the baseball traveled. So it traveled 18.3 units. But to get the number of feet, we have to multiply that by 9. Somebody take 18.3 times 9. Tell me what it is. 164.7 feet. That's how many feet that baseball traveled. From the pitcher to the batter and to the batter to the shortstop. Okay? All right, distance formula. Some of your problems will involve triangles like this. Find KL, the distance. Distance to KL. Okay? To do this, first step, we need to find the coordinates. Where's K at? Where is K at? Who haven't I called on? Isaiah. Where's K at? 1, 3. Very good. And where is L at? Braden.
3, 2.
Not 3, 2, but 3, negative 2. Okay, careful with the negatives. All right, so we take the distance formula. How do we apply the distance formula to this? Jordan.
3 minus 1.
So you take 3 minus 1 squared plus, and the second part, Jordan?
Negative 2.
Negative 2 minus 3 squared. So you get 2 squared plus negative 5 squared, which equals 4 plus 25, which is a square root of 29. Okay, rounded to the nearest tenth, it says. Time to grab your calculator. What is the square root of 29? 5.38, round to the nearest tenth. 5.4. Okay? So, that is that. Okay? So, on Savas Realize, you have like 9 problems to do over distance midpoint and like a 3/5 of the way or whatever problem. There'll be one of those on there too. A couple word problems. So you have like 9 problems to do. If you aren't sure that you did your constructions right or want to look over it or want to grab your constructions before I grade it, the constructions are on my desk. I'll give them back to you. Okay? Otherwise, get on to your homework, please, on Savas Realize.